Hello friends, this is Suresh, SME in Automotive Engineering. I believe all of you might got some idea about die designing basics from my first series. With all your support and motivation, I am very happy to move on my second series, which is Introduction to Die Manufacturing. If you still not subscribe my channel, please subscribe immediately to get future videos. So I bring a concept of IPO model in die manufacturing, that is nothing but input, process, output. The similar concept I have shared in my previous modules also, because every output is dependent of multiple inputs and processes. So in our die manufacturing, inputs I considered die design and detailed manufacturing drawings. Number 2, manufacturing planning. Number 3, bill of material. And the next stage is the manufacturing process, that start with the machining process, finishing process, and assembly and tryout. The next is output of sampling and inspection. We will see one by one in the upcoming slides. Number 1, die design and detailed manufacturing drawings. I have categorized into 2 types. Number 1, 2D drawings. 2D drawings are nothing but blueprints of the die design, where all the details are shown. It consists of die layout, die design details, accessories. Individual accessories drawings are given to toolroom personnel for manufacturing the components of the dies. Next, 3D drawings are also known as virtual drawings, as we can see the objects in solid form, and this helps for better visualization and used for machining process like a CNC machine. And nowadays 3D drawing softwares are very much useful, and we can directly convert from 3D to 2D for the toolroom activities also. Number 2, die manufacturing planning is nothing but manpower planning, machineries planning, supporting resources planning in detail, considering the delivery of the die to the customer. Chalking out the detailed work plan helps in better project management to utilize time resources efficiently. Also, everyone of the team aware of the delivery dates. Number 3, bill of material, that is BOM list. Every drawing you might have seen this list, which has 2 types. One is in-house manufactured items, second is standard parts, which are called as bought out parts. In-house manufactured parts like forming punch, blank holder, cavity, strippers, and other plate items. And standard parts like we procure directly from the standard part manufacturers like bolt, dowel pins, standard punch, die button, retainers, standard cam units, coil springs, wear plates, etc. Moving to process stage, which is die machining process. I have categorized into 2 machining process. One is 2D machining, is consisting of conventional machining process like plate sizing, casting machining, drillings, chamferings, etc. And 3D machining, which is the special machining process with the help of CAM software programming in the CNC machines. Number 5, finishing process. Finishing process I divided into 2. Number 1, bench work. Number 2, surface finishing. The bench work activities like tapping, mating part preparation, stoning, removing the milling mark, steel squiring, polishing the die, and keeping the die ready for next stage. The 6th is assembly and tryout. So assembly I have made 2. One is die assembly and next is spotting and tryout. So under die assembly, all the components which are manufactured in-house and bought out from the suppliers, we assemble as per the die design and drawing, verifying all the quality before it goes for spotting and tryout. And the spotting and tryout activity is checking the clearance part, making the surface contacts, and taking the initial samples. At the output stage, sampling and inspection, I have made two. One is a visual inspection and number 2 is a part scanning. So under visual inspection, the die maker inspects the panel on visually to identify any formability related issues like wrinkle, split, any waviness, any buckling and burr issues, cutting issues which are visually seen. And next is part scanning or CMM measurement with respect to the CAD integrity checking as per the customer requirement, and then planning for the die modification to get the quality to the expected level. Chaliye, let's have a quick recap. There is a 7 stages of die manufacturing step. Number 1, die design and detailed manufacturing drawings required as an input, and die manufacturing time planning to meet the customer schedule. Then bill of material preparation for categorizing in-house and bought out parts, and die machining process which is 2D and 3D, then finishing process of bench work and completing the finishing activities, then assembly and tryout to do the spotting and taking the initial samples, then verifying the sample quality through visual inspection and CMM or scanning machine. Hello friends, this is Suresh, SME in Automotive Die Engineering. We will continue on die manufacturing process through IPO model which I shared in the last module. Let's have a quick recap on the IPO model. So IPO is nothing but input, process, output. Input, there are 3 inputs I considered. One is die design and detailed manufacturing drawings. Number 2, manufacturing planning. Number 3, bill of material. Then in the process, machining process, finishing process, assembly and tryout process. Then the output comes as a sampling and inspection. So today's topic is 2.1 die design and detailed manufacturing drawing. There are 2 categories. One is 2D drawing and second is 3D drawing. Why we need the die drawings in 2D and 3D, and what are the requirement for preparing this? As you know, without a die drawing we cannot make the complete die set with the expected quality. So 2D and 3D drawing includes number 1, manufacturing process flow chart. Everyone might aware about the flow chart. Flow chart purpose is to give the high level process steps of any manufacturing process. Number 2, process details. Process details are nothing but what are the process involved in manufacturing the component. They are nothing but blanking, draw, trim piers, flange process, etc. Number 5, detailed child part details. We need to cover each and every child parts for manufacturing them to get the die assembly. Every part detail required for manufacturing, whether it is a small part or a bigger part. Without drawing we cannot make to get the accuracy level. Number 7, detailed machining drawings. So each and every die undergo multiple process of die machining. So there are few important drawings we need to make for a specific machining process, so that easy for machining the blocks with the specified machine. Number 8, detailed hole charts for drilling and tapping. If you see, for making the even simple die requires minimum 100 holes with 70 to 80% of tapping holes for assembly. So you can understand for the importance of dedicated drawings for drilling and tapping and making the each and every hole. We will see in the upcoming slides how the coordinates given. And number 9, fastener details. As I said, 70 to 80% tap holes in the die manufacturing. So there we need to use a different type of fasteners, standard, and some of them are manufactured. So that details also, each and every small details also we need to give in the die manufacturing drawing. And number 10, raw material details. Many types of material used in die manufacturing with respect to fit and function. Hence each drawing should have what is the raw material and what size we need to cut and what size we need to size it in the rough machining. Then heat treatment detail, few elements of die parts required heat treatment to achieve a hardness to form or trim or piercing. So drawing should specify the method of heat treatment like through hardening or case hardening, so that the right function, the right process followed to make the heat treatment. Number 12, machining process. So drawing should also cover lathe, milling, MOTR, surface grinding. So these processes are also important to capture in the machining process drawings. Then clearance details. Clearance details are important for fits and mating parts. So every dimension should have the clearance details. If we don't have a specific clearance detail, then we can use the standard template to identify the clearance. Then the standard details. So standards details cover the tolerancing or the standard parts usage in the dies like cams, springs, any other standard parts. And the 15th is 3D models required for various machining process as well as inspection and analysis. Then the last thing is every drawing should have a document control status, so that we can refer the drawing and what is the level of drawing, and if there is any revision we are doing, so that also we need to keep updating, so that we can use the latest drawing for the manufacturing and maintaining the dies. And document authorization, so who has prepared, who has reviewed, who has authorized, these details also important as part of document authorization before it goes for die manufacturing. Then the last thing is document ownership status. So who is the custodian of the die drawings, and who is going to be the owner for the die drawings, like it may be proprietor or it may be the design department. So these are the 2D and 3D drawings requirement I have captured. Then next let's see one by one about these details. Manufacturing process flow chart and process details. Here I am showing a simple flow chart for manufacturing the body side outer. Starts with OP10 blanking, and some company call OP05 for blanking, and OP20 drying, OP30 trimming and piercing, OP40 trimming and restrike, OP50 flanging, wiping, piercing, OP60 trimming, piercing, OP70 flanging and trimming. So these high level 7 stages are called as flow chart to get the blank stage to finish part. And you can see the process detail blank here. The outline is the blank shape, and the draw shell is given in OP20. OP30 you can see the trimming, which are the portions are trimming in the OP30, and then OP40 the green colors are trimmed in the OP40. Then OP50 you can see there are few trims and there is a flange happening here, and OP60 you can see the restrike and trimming cam piercing operations, and OP70 finish panel. So this is the sample for process flow chart and process details. Next we can see detailed assembly drawing. Any die drawing should have the one complete page which is having the die assembly condition view, and then from there we pick up the parts like a human body, the way we show eyes and ear. Likewise we need to show in one complete assembly drawing the important segments and few of the cut section views and other details to give the complete picture of the die. And then child part details, as I explained, each and every part we need to capture in the 2D drawing. And this is a backup plate, and this is a support insert for the progressive die, which I will show you in the coming slides. And this is the lifter pin to feed the strip, and this is a rail lifter to get the strip feeding. and this is the key for assembly of the plates, and this is the guide rail for guiding the strip, and whole charts and tapping details which I explained in the previous slide. Here I will show you the example. This is the slide driver, and you can see in the small block there are 8 holes are there, and they are in different circle design, and we need to capture all this drawing with the dimension of x, y. Then it becomes complicated to understand for the milling machine operator. So to make them easy, there is a small table we create that, and we make the whole position only A1, A2, A3, A4 and B1, B2, C1, C2 depends on the whole design. The codification is given, and then you can see in a simple form x and y coordinates given for each hole. So a normal milling operator with the MOTR setup, he can make the drillings as per the axis given easily. If we don't give, then the drawing may look like difficult to read, and there is a chance of error by the milling operator. And then you can see the hole also, what is the hole and what purpose, and which are the holes for tapping. And you can see the hole which is having a counter bore, and the cut section you can see which are having a counter bore and which are having tap design. So you can see that corner 4 holes which are A series are a counter bore for assembly, and then C1, C2 is nothing but tap hole, and the dimensions are in inches, not in just for the reference I am showing here, so you can use this as a reference. And then third one is a kind of again another hole with a pre-hole and a secondary hole, and you can see the other one slide yoke, and then the slide. Similarly, every drawing, whenever there is a more holes, we make the small x y axis table, so that the operator able to finish them quickly without error. And then this is the stripper plate for the process. And tolerance and heat treatment, you can see every drawing and every dimension, if we start giving the tolerance, that is also difficult to read for the operator. So there is a tolerance table given. If there is no tolerance is given, the operator can use this standard table so that he can refer the tolerance specification. And then you can see this punch forming punch getting a flame hardened, and through this the surface only getting hardening. And you can see the detailed process drawing for the die block forming. Here there is a typical form is there, and this is very small form, and operator used to make sometime error, and then we create the section or the detail with the extended form. Like here I am showing 5:1. This makes it easier for the die manufacturing operator to read and then to set the angles and values, so that the accuracy level get maintained as per the die design. And you can see this is die block, and then there is a trim blade, and you can see here the heat treatment again given in the trim insert. There is a requirement of 59 to 61 HRG, which is through hardening, and material also different A2 material. If we don't give, then there is a chance of making the error like a case hardening or the wrong material selection. And you can see here the form die inserts. And then next one more detailed process drawing. If you see this block shape, it is not any small shape, rectangular or a square or circular, and you can see multiple angles have been machined, and then the shape is looks like somewhat a special shape. So during this special shape manufacturing, there are more chances to make the mistake, and then the mistakes causing for the scrapping of the die block. So the die designer during the design, he has to make as many as possible cut sections to make the easier for the die manufacturing operator. It may be in the milling machine or CNC machine with the different angles and giving the references. So you can see view C how the block looks, and then view D, same block in the different view, how the holes look. Then the next one is die block. You can see the details and trim inserts. Very small insert, you can see this insert is being fitted at this small location, but still it has given the clearly with all the dimension in detail, and this is the actual size, but this is given in the big size for the operator. And next you can see such a long big plate in the progressive die with more than 100 holes, and this is the top plate, and you can see starting to end number of holes with the assembly of the back plates, assembly of the stripper plate, punch retainers, everything, and in one the setup mostly this plate get manufactured, and this is the whole XY axis coordinates. You can see the big list I am showing here, which is easier for the operator, and he goes and in one setup he completes. And this is the bottom plate. Similarly, you can see there are a lot of holes, cutouts, slots, and lot many details. So friends, you can understand what is the drawing importance in the 2D for the conventional machining process. And coming back to the 3D, as I explained, 3D drawings are required for not only visualization, they are required for a special machining process and inspection, and this also used for analysis of the die design. And this is a simple image I am showing here for fender manufacturing, LH and RH draw die, and this is a cam trim die and vertical trim die. So this portion getting trim in vertical, and this portion getting in the cam trim. And the cutoff die, which is nothing but parting of LH and RH, and we have the cam operation also here. And then the next is flange and forming die. So the outer flanges getting flange, and there is a restrike also happening, and then the cam action, flanging and forming die. So the flange joggles are getting made in the cam flange, and then cam piercing, the holes which are in the sides, you can see the cams are given, and then the cams are getting used for piercing. So let's have a quick recap, friends. Die design and detail manufacturing drawing includes number 1, manufacturing process flow chart, process details and drawings. Number 2, detailed assembly drawings, child part details and drawings. Number 3, machining drawings with hole charts for drilling and tapping. Number 4, raw material, heat treatment, clearance and standard details. Number 5, 3D models are required for various machining process, inspection and analysis. Number 6, document control, authorization and ownership status. Hello friends, this is Suresh, SME in Automotive Die Engineering. We can recollect the IPO model in die manufacturing for few seconds, and let's understand about the die manufacturing planning in detail today. First of all, why we need to have die manufacturing planning? You can think for a while. Yes, we need to deliver the die on time with the quality at the best price to customer. We all know that famous quote, good planning is half done. The planning is very important. The planning phase comes at the start of the project, which includes defining the activities, sequencing the activities, resource estimating for activities, duration and effort estimation. So we will see one by one. Defining activities is nothing but the high level processes in die manufacturing are broken down into high level activities. That is pattern making, casting, 2D and 3D machining. Many people use work breakdown structure as one of the tool which is used for making the high level activities broken into a separate task. So we can see in the upcoming slides. Second is sequencing activities. The activities identified in the defined stage should be sequenced based on execution order. It is critical to the time and saving the cost. Also, while sequencing the activities, interdependencies should be considered. For example, piercing punch outer diameter finishing after the heat treatment. Next is number 3, resource estimating for activities. The estimation of amount and the type of resources required for activities is done in this step. Therefore, we should have a clear understanding about the processes and the resources allocation in order to manage efficiently. For example, dies are manufactured in one die shop and you have only one 5-axis CNC machine to do 3D machining. Likewise, we can say many resources will be common and it is very important to estimate the resources accurately. Number 4, duration and effort estimation. Duration is directly linked with delivery to die to customer and hence this step should be completed with a higher accuracy. Using work breakdown structure along with the critical path method to complete the die on time. This should include few correction loops also for quality improvement. This is the Gantt chart which includes high level activities and the time duration for completion. Typically, the time ranges from 12 months to 14 months for manufacturing the larger Class A automotive die sets. However, entire process can be completed in 6 to 12 months if the dies are small and medium in size, which are Class B and Class C. You can also comment in the comment section about your company's timelines for the manufacturing of the dies. We can see the phases wise in the next slide. As we covered die design engineering details in my previous playlist, here we can have a quick summary. Those who did not see in my previous playlist, please watch later. Number 1, preliminary die process, which is a high level study. Number 2, preliminary feasibility and simulation. After the preliminary die process, we need to do feasibility for the process and simulation results. Number 3, die process finalization. Number 4, full cycle simulation, compensation and morphing. Number 5, then the die designing. Number 6, FMEA to identify the failure modes. And number 7, milling parts for 3D machining. Next is sourced activities. Once die design frozen, we go for pattern and castings. So number 1, pattern. You can see the thermocol pattern for a die with the important details like front, center, casting grade, part number details, upper tool, lower tool, what is the stage. Likewise, after pattern approval for the rib position, thrust location, backup blocks, guides and lifting arrangement, then we go for the casting phase. Then the core activity of die machining starts. 2D milling, 3D milling, die assembly, dice tryout, automations and systems, quality loops, and the last is buy-off. So let's have a quick recap. Die manufacturing planning phase includes number 1, defining activities at the high level and using the WBS. Number 2, sequencing them step by step. Number 3, resource estimating for activities. Number 4, duration and effort estimation. So let's go for the today's session 2.3 bill of material list, that is BOM list. Once again we can recollect the IPO model in die manufacturing for a few seconds, and under the input the third one is a BOM list. So this is a very simple small tool with various parts mentioned in the drawing, but if you just think through whether we will be able to manufacture die along with these minimum informations, no, not possible. These are high level informations and we need each and every part of the die elements to be mentioned for complete manufacturing of the die, and that is the item which we call bill of material. That includes all elements and accessories of die sets. How you will be seeing in the die drawings with the call out numbers starting from 1 to many numbers, depends on the die size, and you will see in the right side there is a tabular column which is starting from the same number system from bottom to top with the many empty cells where we are going to see the details are getting filled. So what are the details we are filling in the die design BOM list? Number 1, die material detail, which is nothing but raw material details of all the die elements. Number 2, all accessories, specifications and quantity detail. Number 3, standard parts along with manufacturer part number details. Number 4, customized parts details. Number 5, manufacturing process and finish detail. Number 6, die surface coating details if there are anything. And number 7, heat treatment process and hardness details. So we will see one by one in detail in the upcoming slides, and I will take through the first item, die material. So in die material I have broadly classified into two designs of die. Number 1, plate based die, and number 2, casting based die. The number 1, plate based die, you can find the various material we are using, starting from holder, which is nothing but top plate and bottom plate, and back plate, punch plate, stripper plates, die plates, and nested plates, and punch and die. So these are the main components, and you can find various material used by the material available in their own countries. And the casting based dies, you can find the top die holder, pad, guide bars, and the bottom die holder, punches, retainer. So basically the top die holder and the bottom die holder, which is made up of FC25, FC30, stripper pad, heel guides, bottom holder. Number 2, all the accessories, specification and quantity detail. In that, the first one is clamping accessories like fasteners, screws, tie rods and nuts. The die designer need to mention the fasteners in detail. Number 2, error proofing and guiding accessories like dowel pin, grub screws, spring plugs. Number 3, the distance bolts, limit pipes, cotter pins, ejector pins, and electrical items like sensor, cable and joints. Automation items like pneumatic hose, connectors, bracket, vacuum cup. Number 3, standard parts along with the manufacturer part number details, which are standard piercing punch, retainers and die button, standard guide elements like guide pillar, guide bush, bear plate, standard cam units, PU items, coil springs, 4, gas springs, manifold items, feeding rollers, and number 5, pneumatic cylinder, vibrators and scrap tubes. Number 4, customized parts detail, which are nothing but tool room, own manufactured profile punch and profile die insert according to the component requirement, and trim steels, then locators, blank support plates, then die balancing blocks, stroke end blocks, scrap cutter and lifter assembly, and some of the customized cam and rotary cams. Number 5, machining process and finish detail. Number 1, metal cutting. This is the table which is showing the range of surface roughness value from the each metal cutting process and grinding process through the abrasive wheels. And taking an example, planing or shaping, the surface roughness value starting from 1.6 to maximum up to 12.5 micron meters. And if I take any abrasive process of grinding or polishing, you will find the polishing from 0.1 micron meter to 0.4 range. So this is very important with respect to the tool manufacturing functionality requirement. We need to know what is the surface roughness requirement. Microstructure view, with respect to cutting tool application, you will find the different forms of geometry, and then you will see the die designer uses this symbol, which is old methodology, inverted triangle, starting from 1 triangle to maximum 4 triangle. And you can see the numbering system also. N1 is the finest form and N12 is the roughest form. And in the drawings you will find nowadays triangle along with the leader line, and also in the bomb list. Number 6, die surface coating details. Surface coatings are important when the die volume is more, as well as we need to prevent from the defects which are related to die surface roughness and even cutting life enhancement. I have categorized into 4 types of coatings. Number 1, hard chrome plating. Number 2, CVD coating. Number 3, PVD coating. And number 4, TD coating. So I will take each and every coating methods in the future with a separate presentation. Number 7, heat treatment process and hardness detail. So heat treatment process is important for the tool manufacturing, and there are 5 types of heat treatment processes there broadly which we are using in tool manufacturing. True hardening process, flame hardening process, induction hardening process, laser hardening and case hardening. And this is an example of HRC range which you can refer. Let's have a quick recap. Bill of material list of die sets includes number 1, die material detail, number 2, all accessories specification and quantity detail, number 3, standard parts along with the manufacturer detail and part number, number 4, customized part details, number 5, machining process and finish detail, number 6, die surface coating detail, and number 7, heat treatment process and hardness detail. Thanks for watching. If you like this content, please click the like button and do not forget to comment and subscribe. Thank you. Bye bye.